Basically, we're talking about parts of a graph or polynomial function or equation that satisfy the equation. Basically, solutions. You can look at roots as solutions, zeros, meaning rational or irrational numbers that satisfy an equation when it's set equal to 0. That's why we're looking at this here. This is where y is equal to 0. So these are some of your roots of any sort of polynomial equation. This would mainly be an x to the third equation, starts here, finishes up here. This is an odd number polynomial we're looking at here. So let's say I present you with a polynomial equation. And they ask, find possible roots, and using possible roots, find anything that could actually be considered a root for this equation. Meaning, you're going to look for possible roots from this equation and then test those roots and find which actually work. So possible roots, basically you're looking at the leading coefficient and your constant term or your ending coefficient here, and you look at this P over Q would be a list of your possible roots. P being your ending coefficient and Q being your leading coefficient. And we understand that when you take the square root of 4, that possible roots or answers or solutions to this is not just 2 or positive 2, but it's actually plus minus 2. So when you're working with, possible roots for, 15 and 1, you're looking not only the positive form of that, but the negative form. And what you also need to be doing is looking at the factors. Meaning, for P, 1 and 15, 1 times 15 gives me 15, 3, and 5. And now my possible or factors for Q, or my leading coefficient, is just 1. Now, you have, or what you want to do is come up with possible roots multiplying P over Q. So basically, plus minus 1 over 1, plus minus 3 over 1, plus minus 5 over 1, plus minus 15 over 1. Those are all your possible roots. And you know that any number over 1 is just that number. So if you're coming up with, we'll just call it possibles, your possibles, it would be plus minus 1, plus minus 3, plus minus 5, and then plus minus 15. Now, these are your possible roots. In order to find out whether or not these actually work, what you want to use is synthetic substitution. It's basically synthetic division. You're testing how these would divide into your equation. Now, what they do is, or what you should do, is make a chart. So you're basically looking at a chart. Here's your possible roots. Okay. Now, you could put any combination of these. There aren't any certain roots that necessarily you should pick. You'll see 1, 3, 5 is a good start. Now you could use, instead of 1, you could use -1. Instead of positive 3, you could use -3. Instead of positive 5, you could use -5. But using positive numbers, that usually works. Now up here in this chart, we're using all our coefficients from our original equation. We're using the 1, the -7, positive 7, and the 15. And this is where signs really come into play. You don't want to mess around and make a mistake with a sign, because then that would lead to a lot of wasted work. Now, how to fill out this chart? Okay, this is it's hard to fill out this chart without running some synthetic division on the side. So if I were you guys, I would run the synthetic division, and this is what I'm going to show you right now. This is the part of the chart that some of you guys weren't totally understanding. So basically what happens is this one will drop to here. And then you do 1 times 1, which is 1. And you're basically evaluating this. You're simplifying this. -7 plus 1 is -6. And then you take this value here and you multiply it to your factor or your possible root here, which would be 1. So then you have -6 times 1, -6, which gives you a -1 here. -1 times 1, that gives you a -1, and that's a 14.
Curious.
Say again? Yeah, that's yep. And then so you're putting in your results. You're putting in results, and you're looking for factors that when you run a synthetic substitution that are going to give you a remainder of 0, meaning that if I were to divide by that factor, there wouldn't be any remainder, which means it goes into, just like anything else, if you have a 80 divided by, 84 divided by 4, it goes in twice. Here's your 8, subtract 4, goes in once. So it goes in evenly, where if it was 5, okay, I have a remainder of 1 here. That's 4 is not a factor. 4 is not a factor of 85, because when I divide 85 divided by 4, it gives her a remainder. Where 84, there isn't any remainder, so 4 is a factor of 84. The same thing went for 15. If I take, what are the factors for 15? 1, 3, 5, and 15. If I took 15 and divided it by 4, okay, it goes in 3 times 12. Oh, there's a remainder of 3. 4 is not a factor of 15. So when you're dividing, basically you're using synthetic division or substitution, you call it, by 1. And because I divided this by 1 using synthetic division or substitution, I got a remainder. I know 1 is not a factor. So, and there's some testing that goes on here. Now I'm going to continue on, and this is good because you'll actually see another, we could say, simulation of this synthetic, I'm going to call it division that we're doing. The 1 goes down, that's the start. Whatever this is here, this comes 1 times 3 is 3. -7 and 3 is -4. -4 times 3 is -12. Which gives me a -5. -5 times 3 is -15. And what do you know? Big, I have a remainder of 0, which tells me that 3, my 3, is an actual factor of this equation here. And I will put in, okay, I have 1, -4, -5, my remainder of 0. Let's see if the same happens with 5. Actually, I don't even want to do that just yet. Why continue on if I know I have a factor? But what I am going to show you is actually, I'm going to come back to this. I'm going to show you. So, what do you do once you have you found one of your possible roots as an actual root? Now, how do I put 3, a positive 3, as a factor in parentheses? Meaning, how do I put it as an x plus or minus something? Well, I know that when I solve for a 0, and if I want this to be like a positive 3, I would have to make it x minus 3, right? If I want the factor to be an actual 3, because when I set this equal to 0, x minus 3 is equal to 0, plus 3 plus 3, x is equal to what? So a lot of times when you have a factor that's a positive number, like here's a positive 3, all the time, and say all the time, when you put in a parentheses, it's actually going to be represented as an x minus that number. Like for instance, if I found a possible root was negative 1, let's say. If I want to put this in as a factor in a parentheses, I would actually call it x plus 1. Because when I set this equal to 0, my x is going to end up being a negative 1. So a lot of times when you see a possible factor or possible root, okay, it's represented as a positive here, like this is positive 3. You put it in the parentheses as x minus that number. So let's look at that. So we have x minus 3. Let me change color here, just so this pops out a little bit more. Let's say x minus 3 is a factor, and I'm looking at my other coefficients. Now, basically this becomes my x squared, my x, and then we'll just say my constant, right? So I have x, and then I have x squared minus 4x minus 5. Notice that this 1 went in front of the x, the negative 4 in front of, or the 1 went in front of the x squared, the negative 4 in front of the x, and the negative 5 is my constant. Now, yes?
Why does it drop the x?
Because I factored out an x. Here I factored out an x. I found negative 3 as a possible root. Okay, so it's basically like I divided, remember that I divided that original, it's as if I, what was it, x3 minus 7x squared plus 7x plus 15. It's as if I divided it by x minus 3. I factored it out. So if I divide this by x minus 3, I actually end up with this here. Now, I look at this, and personally I see an unfoil. I see that I can use the 5 and unfoil that to an x. Now I know it's negative, so I want my bigger number to be negative, so I'll say x minus 5, x minus 1. I just unfoiled this here. I did that here. That's why we worked on that earlier this year. That's an important skill. That saves you a lot of time. That saves you a lot of time on the SAT. Picking up on that, that's a very common, you're seeing, oh, okay, I know 1 in 5. I know a negative 5 and a positive 1 would give me a negative 4. So there's my factors here. Now, take a look. If I were to look at the x minus 5, that ended up being a factor, right? Which would mean if I did synthetic substitution with the 5, what should be the remainder?
0.
It should be 0. So, and let's test that. So x, oh, I'm sorry, this should actually be a plus 1. A plus 1. Right? Because if I want my inside to be negative 5x and my outside to be positive 1x to give me that negative 4x. So then I have the 1, negative 7, plus 7, and the 15, 1, 5, which is negative 2. I'm speeding up, that makes me nervous. Negative 10, that's a negative 3. Negative 3 times 5, negative 15, that's 0. Now understand, if I tested this before I tested this, the 3, if I tested the 5, I would have had the same thing. And this, x5 is really, or this possible root of 5 is really x minus 5, and that's what I have here. Now look, this plus 1, which is really represented as a negative 1, this should also give me a remainder of 0. And if I did negative 1, 1, negative 7, 7, 15, I'm showing a lot of these synthetic divisions because this is the technical part with a lot of steps in it. 1 times negative 1, that's a negative 8. That's a positive 8. That's a 15. 15 times negative 1, that's a negative 15. Again, I have a 0 as a remainder. So you can see. Now you could actually even run this same rational root theorem right here. The same thing that we did for this here with this piece here. I don't want to go through all that if you can't find this unfoiled. Okay? Now, what this does is it basically gives me this polynomial equation. It gives me that in its most factored form. And what it's telling me, or gives me the ability to do, is it allows me to find all my roots, meaning if I set this equal to 0, if I make any of these parentheses 0, 0 times whatever these is still going to be 0. I need to make these zeros. If I find a value for x that when I subtract it by 3 gives me 0, 0 times anything gives me 0, and that's going to give me on the spot in the graph where the graph intersects the x-axis. So I have x minus 3 is equal to 0, x minus 5 is equal to 0, and I have x plus 1 is equal to 0. You have the plus 3, x is equal to 3, plus 5, x is equal to 5, minus 1, x is equal to 1. So my negative 1. So my roots are 3, 5, and negative 1. And if I wanted to give a rough estimate of a graph, of how that graph would look, I think it would be negative 1, 3, and 5. It would look something like this, where you have an odd function where it starts in one direction and ends in another, and it's positive, so generally you would end in an upward direction at the end. And that's where your possible values are here. So that's taking that original function all the way through synthetic division, finding roots, and then getting a graph here. Now, if you want to check your work, I suggest you put that function into your calculator, your graphing calculator, and then you could actually use some of the